Algebra. Arithmetic is a branch of maths that deals with numbers, operation on the numbers like addition, subtraction, multiplication, and division, and various properties like commutative property, associative, distributive, inverse, and identity. Geometry is a branch of mathematics that deals with 2D shapes like square, rectangle, and so on. 3D shapes like cube, cuboid, and the properties like area, perimeter, volume. So these all comes under geometry. Algebra. Now what is algebra? Algebra is a different branch of mathematics in which we can see the usage of letters. So here we will specifically see these letters. Along with the numbers, we can see the letters as well. But why we need letters? Just try to recollect the area of rectangle. We usually represent it as LB. L and B here means length and breadth of a rectangle, as rectangle can be of different sizes. To generalize the formula, we have written it as LB. So whenever we take a rectangle, we will substitute those numerical values in the place of L and B. From this, we can understand that we use letters to represent a numerical value which may change. Means these letters, they don't represent any fixed value, they take varying values. Matchstick patterns. We can make different patterns with the help of matchsticks. Say if we want to do letter L. For this, we need two matchsticks. One is for the vertical line and other one is for the horizontal line. This makes one L. If you want to repeat it or to make two L's, we will just repeat this and so on. We can repeat for creating different number of L's. So from this, we can observe that to make one L, we need two sticks. For two L's, we need four. For three, six, and so on, depending upon the number of L's we want to make. This can be generalized so that if someone asks how many sticks are required to make 10 L's, we can't keep on doing this until the number of sticks. For avoiding such problems, we will generalize the rule here. Observe this pattern when we have 2 sticks means 2 into 1 is giving 2 sticks. So 2 L's means 4 sticks. How to get 4 using 2? 2 into 2 is 4. Again 6 sticks for 3 L's. How to get 6 using 3? We have to do 2 into 3, that gives 6. By observing this, we can make the number of sticks required to make a particular number of L's is just 2 times it. Then the formula can be generalized like 2 into n, where n stands for number of L's we want to make. Take the previous case. When we say how many sticks are required to make 10 L's, we'll just place 10 in place of this n, means 2 into 10, that is 20. 20 matchsticks are required to make 10 L's. Like this, we can make any pattern and generalize it variable. Now in the rule we have seen just now, it is 2 into n that is required to make n number of L's. Here this n whatever we have is called as variable. The letters that we use here are called as variables. We can also call them as literals. Variable, from the word itself we can tell that it is a varying value. Is from vary and it means a change. So about variable, we can tell that it is not a fixed value and it can take different values. Now let us try to create another pattern and see how to use the variable. Variables can take any letters like A to Z, whatever we have the letters, we can use those letters to represent the variable. If we want to make C, 1C, it requires 3 matchsticks. To make 2 C's, we need 6. Similarly, for 3 C's, we need 9. Now, if we observe this, the first C requires 3 sticks. So, 3 can be obtained by multiplying 1 with 3. That is, 3 into 1 is 3. In the second case, we need 6 sticks, which can be obtained by multiplying 2 with 3. And in the third case, multiply 3 with 3 and it gives the 9 sticks. With this, we can generalize the formula that 3 into n is the count of sticks required to make n number of C's. This rule can be used to answer questions like how many sticks are required to make 9 C's. Now, in place of n, just substitute 9. 3 into 9 is 27, and 27 gives the answer of how many sticks are required to make 9 C's. Now, this concept is fine. We are just making different patterns using the matchsticks. But where do we use this algebra concept in real life? Say we eat a specific type of chocolate which costs 5 rupees. Now we want to distribute the same chocolate on our birthday in our school. Say it has got 100 students. So how much budget you need to buy chocolates for all in your particular class? For that you need to know 5 into 100 gives 500 and we need 500 rupees. In a different case, you may be required to buy only 5 chocolates. Even in that case, what will we do? 5 into 5 is 25 rupees. We need 25 rupees on that particular day. So, how we are making this? How we are able to estimate the amount required here? For that, we are using a general rule that 5 multiplied by number of chocolates we need to buy gives the amount. So this is again a algebra concept 5 into n where n represents the number of chocolates. Like this in different cases we can use the concept. Say for example it's a Republic Day celebration in your school and there is a performance to be done in the presence of a guest. And for the performance only 10 rows can be accommodated in the playground and each row we can make only a particular number of students to stand. So, from that, to pick the students from a huge crowd to do the performance, how will we decide? It would be like number of rows we can into number of children in each row that can stand and perform freely. So that say 10 rows and each row can accommodate some 8 children. So 10 into 8 is 80. These values may vary depending upon the area of a playground. So in general, how do we make that number of rows into number of children in each row? That gives number of children to be picked to perform in the presence of a guest. In this way, to make different decisions, we need to apply the algebraic concepts. So they help us to solve different puzzles and also to arrive at a conclusion in different situations. For this particular chocolate case, we can generalize this formula as 5 into x that gives the number of chocolates required in different situations. While using these variables, they can be used in different branches as well. We have seen that arithmetic is a branch, geometry is a branch. Even in those branches, we are using these variables. Let us see where we are using it. Say in geometry, we write the area of different shapes, perimeter of the shapes, say perimeter of square. How do we represent this? 4L. 4L. L is a variable. It's a varying value. Depending upon the length of side, we substitute that particular value here to find the perimeter. Similarly, perimeter of rectangle, we write it as 2 into L plus B. L and B represent length and breadth. We use algebra concepts in different places. In arithmetic also, to write the commutative property, distributive property, we use these variables. Say for commutative property, we write it as a plus b equal to b plus a, where a and b represents two different numeric values. So instead of writing the numeric values as it can be any value, we are just using a and b in place of those unknown values. For the distributive property, we just write it as a into b plus c equal to a into b plus a into c. Here also we are using the algebraic concepts, that is using a variable to represent a varying value. Expressions with variables. Expressions is when we use only plus, minus, into and division size among the numbers, we call it as a expression. Say here 4 into 3 plus 5, this is a expression. This expression can be evaluated and we can get a value here. On doing this evaluation, we get 17 as a value. So this is equal to 17. While understanding a variable, we know that variable represents a number. We can do different operations on numbers in similar way. We can perform different operations on variables as well. But the expression that is formed so cannot be evaluated, means it doesn't give any direct numeric value until unless we substitute a particular number in the place of a variable. We'll see different expressions now. Y plus 5. This means we are adding 5 to y. Here we are doing addition. T minus 7 is subtraction. This expression involves subtraction, subtracting 7 from t. 10a, which means multiplying a with 10, x upon 3, that is dividing x with 3. In this way, even with variables, we can do different expressions. We can do all the operations on the variables. Practically, where do we use these expressions? Let us see that. Say we have a statement that Sarita has 10 more marbles than Amina. We don't know how many Amina has got. So, how can we write an expression here? Amina might have got 3, 5, 7, or so on. For that, we will just assume that Amina has got x marbles, then Sarita will have x plus 10 marbles. Now, if someone says that Amina has got 3, then how many Sarita will get? 3 plus 10, that is 13 marbles. In this way, a algebraic expression can be evaluated only when we substitute a numeric value in the place of this particular variable. Let us look into another example. Ramu is 3 years younger than Raju. We don't know the age of Raju, but we just know younger means smaller than Raju. So, whatever the age Raju has got, we need to subtract. Say Raju is x years old, then Ramu's age can be calculated as x minus 3. As younger means less, less means subtracting minus 3. We will substitute the values here and that gives a particular number which represents their ages separately. Next, we have looked into addition and subtraction operations. We'll see into multiplication now. Sita is twice as old as Lata. We don't know Lata's age, so let it be x. And Sita is twice. Twice means multiplying any number with 2. So it's a multiplication operation. So Sita's age can be 2 into x. Here we are doing multiplication. Now we will do into how to perform division on variables. Say Susan scored half marks only. We don't know what is the total marks here. It could be 30, 20, 40, or 80, anything, or 100. It can vary. So in place of total marks, we'll take it as x. And to obtain Susan's marks, we will just divide this x with 2. X upon 2. This gives the marks of Susan. Like this, in real life, for different statements we can write the algebraic expressions. Expressions means it involves only addition, subtraction, multiplication, and division. Now we'll see the equations. What are equations here? Consider the previous case where we have written that 2n matchsticks are required to make n number of L's. We have 10 matchsticks with us and we want to find how many L's we can make. How to do this? Using the rule we have created, that is 2n. We will first equate these two things. 2n gives the number of matchsticks. We have 10 matchsticks. So equate these two. 2n equal to 10. From this we will get the n value. Here we know, as it's a simple equation, n equal to 5. 2 into 5 gives us 10. So we can immediately tell this to be n equal to 5. Here, if we observe 2n equal to 10, we are using equal to sign. So this is called as equation. Previously, we don't have equal to sign while writing the expressions. They have only plus, minus, into, and division. So those are expressions. On using the equality sign here, this become a equation. The value whatever lies towards the left of this equal to is called as LHS, and towards the right of equal to is called as RHS. So this LHS will be equal to RHS. This is a equation. Now we know n equal to 5. On solving this, whatever we get the value of n, this is called as a solution. So the value of variable in a equation which satisfies the equation is called solution of a equation. So only for 5, this particular equation is true. If we keep any other value here, this can't be true. So that particular 5 is the solution of this equation. Take, we'll take another equation. X plus 10 equal to 30. This is a equation because we are using equality here. So how to solve this? What is the solution of x? We can keep different values and see whether the left hand side and right hand side are getting same value or not. Say if we take x equal to 5, 5 plus 10 is 15. On left hand side we have 15 but right hand side is 30, so 5 cannot be a solution for x. On using a trial and error basis, we can know that x equal to 20 is solution for this particular equation. Like this, we can use the trial and error method or use transpose technique to get the solution for an equation. We'll see the transpose technique in a different video.